Hello my dear students, I welcome you to NEET World. So in this session we will be discussing types of chemical reactions. Okay, so in the last session we had started discussing about types of chemical reactions where we have covered combination reactions and the next decomposition reactions. There are this many types of chemical reactions here. So first one is combination reactions where two components will combine, when two reactants will combine to form a product, like A and B are the two like separate components which are combining to form a single product. So that is what happens in the combination reactions, right? And the next, what happens in the decomposition reaction? So in the decomposition reaction, so this whatever the compound is there, that will be separates out, like decomposes to respect to elements here, right? So this is what seen in the decomposition reactions. So these two things we already covered in the last video, right? So in this session we will be discussing about displacement reaction, double displacement reaction, and also about precipitation reactions. Okay, so here I have brought very nice examples, so listen here very carefully, everything will be very clear. Okay, very simple reactions these are. Look here. So what is a displacement reaction? Okay, it's a displacement reaction. See, displacement reaction is a type of chemical reactions where a more reactive element displaces a less reactive element from its compound. For example, BC is a compound, let us consider. Okay, now let us say this B is less reactive compound. Now this less reactive compound is displaced by this more reactive element A. Therefore we are getting AC as a product, and B is a displaced out from this BC. So therefore we are getting AC as a product. Now which is more reactive element? Here A is more reactive element which is displacing this B from its compound. I hope it is clear. So what happens in the displacement reaction is clear here. Okay. Now where A is more reactive than B. So always remember, a more reactive element will displace as a less reactive metal from its like compounds. Okay, now I will be showing you one simple example. Look here. So let us take displacement of copper by zinc. So displacement of copper by zinc from copper sulfate solution. So what is the solution here? See, here I told you BC, right? So instead of so for this BC place we are taking copper sulfate solution, and what is our A here? We are taking zinc, which is a more reactive metal than this copper. Therefore this copper is displaced by this zinc. So look into this example here. I have shown the picture also here. First of all, let us discuss about this reaction, then we will look into the like experimental observation. Look here. So we have a zinc metal. Okay, so now we have copper sulfate solution. So in this copper sulfate solution, we know this is having blue color solution. Copper sulfate solution is a blue color solution. Okay, now what happens is, whenever we are adding zinc granules or when zinc rod is dipped into the copper sulfate solution, so what happens here is, so this copper is getting displaced as a copper metal. See, copper is displaced as a copper metal, and now to this position the copper is removed from here, and to that position we got zinc. So zinc ZnSO₄, zinc sulfate is formed. So this is what happens during the process. Now one metal is displaced by other. So copper metal is displaced by zinc. Why it is displaced? Because zinc is more reactive than copper. Therefore zinc will displace this copper from its copper sulfate solution. I hope it is also clear. So if you want, you can look at into this experimental observation. See, copper sulfate is a blue color solution. To that, so we have a zinc rod which is dipped into the copper sulfate solution. Now what happens? The intensity of this blue color solution will be decreases, because the copper +2, the copper from the copper sulfate solution which is responsible for the blue color, the copper will be like converting into its like metal. So here it will be in the +2 charge, so it will be converting into respective element like metallic form, right? So what happens? The solution intensity, color of the solution will be decreases, the intensity of the solution will be reduces, because now it is converting into zinc sulfate solution. It is not anymore a copper sulfate solution, it will be now forming zinc sulfate solution. therefore the color will be disappears, the color will be faded out. So this is what you need to understand here. Okay, I hope it is clear. So what are the observation here? A piece of zinc metal is added to the blue copper sulfate solution. The zinc metal gradually disappears. So whatever the zinc metal we are adding, so that will be gradually disappears. Disappears means that zinc metal converted into what forms? Zinc sulfate solution, right? So that's why it is disappears. The blue color of the solution fades, right? It will be fades out because now it is not anymore a copper sulfate solution, it is becoming zinc sulfate solution, right? Then next, a reddish brown deposit of copper seen on the zinc. So whatever the zinc rod is there, so on that zinc rod we will be seeing some deposition of this what? Zinc, like this copper whatever formed here, that will be deposited on this zinc rod. So that will be having like reddish brown color. Okay, so why that reddish brown color is depositing here? Because of copper is forming, right? That will be deposited on that rod, whatever the zinc rod we are taking. Okay, whereas zinc is dissolving into the solution and converting into zinc sulfate, right? Okay, this is what we need to understand. From this, so what we can say, zinc is more reactive than the copper, so it displaces copper from its copper sulfate solution. So this is the point which we need to remember. Okay, so now finally we have a conclusion here. Whenever we have a more reactive metal, that more reactive metal will displaces a less reactive metal from its solution, right? Okay, so now we need to know the key points here. So the key displacement, the key to displacement is what? Who is more powerful, or who is more reactive? Who is more reactive? This is the point we need to understand. This is the point we need to catch. Then we can easily decide whether this displacement reaction is possible or not, right? Okay. Now look at here, the reactivity series. So now in order to understand this, which is more powerful or which is more reactive, we have a series of elements where the metals are arranged in their reactivity order. So the reactivity series is a list of metals arranged in the order of their decreasing reactivity. So at the top we will be having potassium, which is more reactive, more reactive metal. Okay, so as we move down the table, so what happens, at the bottom we will be having less reactive metal. Okay, now whatever the metals which are at the top are more reactive, therefore these top metals will displace the bottom metals easily from their solution. Okay, I will show you, give me some time. Okay, so now metals higher up, so which are the metals which are at the top of this series will displace the metals which are at the bottom of their salts, from their salts, right? This is what we discussed. Okay, I will show you here. See, so these are the metals we have I have collected over here. See, potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, next iron, tin, lead, hydrogen, copper, mercury, silver, gold. So these are the metals and some other elements also present here. So now see which is at the top of this order. So potassium is the top of this order. Therefore I can say potassium will be the most reactive or most powerful metal out of this given series, right? So it can displaces the other metals from their respective solution. See now in the previous case what we have studied about zinc. Okay, zinc, which is displacing copper from copper sulfate solution. So look into the table, see zinc is here, so zinc is over here and copper is over here. So which is more reactive according to the table? So zinc is more reactive, therefore zinc will be displaces this copper from its copper ions from its copper sulfate solution and giving us zinc sulfate solution and what? Copper metal is deposited. Okay, this is what we have seen, right? So zinc should be in the solid form, this is in the aqueous state because it is a pure metal, and here it is in the aqueous form, and copper metal is formed here. So I am writing it as solid. Okay, like this. Okay, I hope it is clear. Now the question will be like this. In the exam you will be seeing a question like this. Okay, so which of the following reaction is possible? They will ask you like that, and they will be giving, so this is the first reaction and they will be giving one more reaction, Cu plus zinc sulfate solution giving rise to copper sulfate copper sulfate plus zinc. So out of this 1 and 2, which reaction is possible, they will be asking. So which reaction is possible? Only first reaction is possible, but second reaction is not possible. Why it will not be possible here? See, zinc is more powerful, more reactive than copper. Therefore, so zinc will only displaces copper from its solution form. So from its copper sulfate solution. But the reverse is not possible because the copper is less reactive than zinc. Therefore, the zinc sulfate remains the same even if we are adding copper to this solution, zinc sulfate solution. I hope it is clear. Okay. Now I will be asking you one more thing here. So generally let us take one copper vessel I have. So what I am saying, one copper vessel I have like this vessel is made up of copper. Okay. So is it safe to place zinc sulfate solution in this or not? Okay. Can I place this zinc sulfate solution into this copper vessel or not? This is the first question. If yes, if it is safe to place, you can write in the comment box as yes, we can place, because there is no spontaneous reaction. See here what we are observing. So if zinc sulfate is added to copper, is there any reaction? No, this reaction won't takes now. Why it won't takes? Because copper is less reactive than zinc. Therefore, this reaction will not be taking place. So that we can place zinc sulfate solution in the copper vessel, but the reverse is not possible or not feasible. See here I have a vessel which is made up of zinc. Okay. Now if I place copper sulfate solution into this, so what happens? So whatever the copper metals are there, metal ions are there, that will be displaced by zinc. It means the whatever the zinc vessel is there, so that will be what? That will be getting damaged. Why? Because all the metal, all this zinc metal will be what? Dissolving into the this solution. Therefore, the vessel get damaged, and due to the spontaneous, due to the natural, spontaneous means it is happening, the reaction is happening, spontaneous means naturally it is happening, right? So due to that reason we should not place copper sulfate solution in the zinc vessel. I hope this is also clear, right? So this is a general life or daily life application. So which metal is more reactive, which is less reactive, based upon that we can decide. Okay. So this also used in the extraction of metal. So based on the displacement reaction only, extraction of metal is possible. Okay. Now one more thing. See here I have mentioned only about metals. Okay. So note, what is the note point here? It is also there for non-metals also. See, non-metals also have a reactivity series. So example here I have mentioned for halogens. So fluorine is more reactive. Fluorine is more reactive than chlorine. Chlorine is more reactive than bromine. Bromine is more reactive than iodine. Okay. So this thing you just remember. We will come back to the application part of this halogen series also, reactivity of halogen also after some time. Okay. See, so this class will be purely based on your 10th syllabus, but once if you are clearly following the class, you will able to solve the even JEE NEET questions very easily. So whatever I have explained previously, so there are similar type of exam previous year questions based on that explanation due to, on this displacement reactions only. Okay. Now look at here. So what here I mentioned reactivity series of metals. So what is the reactivity series of metals? So sodium, like I have mentioned a few elements from the previous like list. I have mentioned few examples here. Sodium, potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, tin I have mentioned. Okay. So now potassium, what we know, the top of this series, the element at the top will displaces all the down all these bottom elements from their respective what solutions, right, from the respective compounds. For example, magnesium can displace zinc from its solution. Okay. Magnesium can displace iron from its solution. Okay. I hope it is clear. Okay. Now tell me whether this iron will displace magnesium from its solution, yes or no? No, it won't displace iron won't displace magnesium from its solution, because magnesium only more reactive than the iron, right? So I hope it is clear. Okay. Now how we are giving the reactivity series of these elements, how we are giving this? So these metals at the top of the reactivity series, have a greater tendency to lose electrons. So the metals which are at the top, generally alkali metals are at the top. Okay, so they are showing more reactivity. Why they are showing more reactivity? Because they have very high tendency to lose their electron. See, for example, sodium I am taking. Okay, so potassium, sodium are there. Now let us take sodium here. So this is an alkali metal. So now it is having more tendency to lose electron. Easily it will loses electron and becomes Na plus, unipositive. Similarly potassium also. Similarly calcium becomes dipositive, right, Ca plus 2. Like that they have very high tendency to lose electron. It means this state is more stable because of inert gas configuration. Therefore alkali metals have high tendency to lose electron and therefore they will be more reactive. So what are the conditions? So we need to check for its electronic configuration. This is one reason. What are the reasons? So they lose electron due to their electronic configuration. This electronic configuration is most stable. Why? Because it is having a neon gas configuration, right? That's why. Okay, and the lower ionization energy. It means the ability to lose electron is easy, therefore it is required very less energy to remove the electron, right? That is what the lower ionization energy. And the next one is low electronegativity. Yes, metals are electropositive and more electropositive and less electronegative. Metals are more electropositive and less electronegativity. Yes, so due to that reason also you can write. And these are the things making them to show their high reactivity. Okay, so these are the 3 points you should remember, the reason for their reactivity. What are the reasons? Due to their stable electronic, the electronic configuration and low ionization energy and low electronegativity. You can remember these 3 points. Okay, and something you will be studying about reduction potential values. We will be discussing about that in the later classes. Okay, so that is about the thing. Okay, now let us take one more example here. So again I have taken a test tube where the test tube containing copper sulfate solution. So copper sulfate solution CuSO₄. Okay, so it will be having blue color. What is the color of copper sulfate? So it will be having blue color. Okay, so this blue color, let me take the color blue. Okay, so this blue color solution, so now into this blue color solution, so I have taken two nails, iron nails. Okay, so this is the first, when we are taking at the beginning of the experiment, the whatever the iron nail I have taken, so it will be having this kind of color. Let us say there is no color, actually that is a pure iron metal. Okay, so now that iron nail, that iron piece, two pieces we have taken, that iron nails, and we have kept in this in this blue copper sulfate solution. Okay, so we have kept this for some time. Okay, after that time, so what is the change we have seen? So whatever the color, blue color is there, that blue color is like this previously at the starting of the experiment, but at the end of the experiment, after some 20-30 minutes, so the color is becoming like this. So all the blue color is faded out. It is something like almost like colorless or very pale blue, very light blue, right, or colorless we can say. So why? What happened here? So according to the series, the reactivity order, what we know, iron is more reactive. Iron is more reactive than copper. Therefore, whenever we are keeping this iron rod in the copper sulfate solution, what we will be seeing, this iron will displaces copper from its solution and forms ferrous sulfate plus copper is deposited over in the solution or into the iron nail. So iron nail taken out from the copper sulfate solution. So this is how the iron nail is appeared now. Okay, so why it is? Because iron is reacting with this solution. So it means copper is deposited out and iron is converting into iron sulfate solution. So this is what the transformation we need to understand from this. So see, iron sulfate is formed, copper is deposited. Okay, so initially what is the color of copper sulfate? It is blue. Okay, after that it is becoming pale color because complete copper sulfate is converting into iron sulfate. Okay, so that is what iron displaced or removed another element. Which metal it is removed? It is displaced or removed this copper from its solution, from copper sulfate solution. This reaction is known as displacement reaction. Yes or no? Yes. because one metal is displaced by the other. Okay, then next example 2 here, displacement of hydrogen by zinc. Okay, so it means so this is also one of the very interesting example. Look here, so let us take one test tube. So into that we have let us say this these are the zinc granules. What is this? Zinc granules, in which we are also like pouring some acid, let us say sulfuric acid, or let us say otherwise we can say HCl also. You can take H2SO4, you can take H2SO4 or HCl. So this any of this acid you can take, and what are the things are there in this test tube now? We have acid as well as zinc granules. So now what happens here is, if you look into this reactivity series, so into this reactivity series, look here, so look here, zinc is at the top. It means zinc is more reactive than hydrogen, right? So zinc is more reactive than hydrogen. Therefore what happens? So whenever we are adding to the any acid, let us say HCl is there, to that the zinc granules are added. So what happens? Since zinc is more reactive, so this zinc will displaces this hydrogen from its solution. So what is the product we are getting? ZnCl2 we are getting, and we will be having H2 gas is liberated in this process. What is the gas liberated here? Hydrogen gas is liberated. So here HCl like H2 gas is liberated. So this liberated H2 will be appears in the form of this bubbles. So from this solution, so we will be seeing some bubbles will be coming upside. So that will be the bubbles you can observe here. Okay, so now if you want to check to that bubbles whether they are H2 or not, so just if we light it up, so there we will be seeing some pop-up sound. So that pop-up sound is due to what? Hydrogen gas is liberating, right? So that gas will provide that pop-up sound. Okay, so what happens? So whenever we are keeping zinc in HCl like acid, okay, it will be forming ZnCl2 and H2 gas is liberated. So zinc granules are added to dilute hydrochloric acid. So bubbles of colorless gas is observed. So that the gas when tested with burning splint produces what? Pop sound. So this indicating what? Hydrogen gas is evolved during this process. Hydrogen gas is liberated. So why it is? The reason here is zinc is more reactive than the hydrogen. So it displaces hydrogen from hydrochloric acid. Okay, I hope it is clear. Okay, then next I told you what is the reactivity order of halogens. Fluorine is more reactive than chlorine, and then next bromine, and then next iodine. So this is the reactivity order of halogens I told you, no? So let us take one reaction, displacement of bromine by chlorine. These are non-metals. Till now we have seen metals, then one metal and one non-metal. Now both are non-metals only. Okay, so now in this conical flask, we have chlorine. What we have? Chlorine, Cl2 aqueous. So chlorine solution we can say. Okay, so it is having some pale green color, right? Okay, now in this test tube I have KBr, potassium bromide. So KBr solution we have. Okay, now potassium bromide will be having a colorless. It is a colorless liquid. Okay, colorless solution. So in this chlorine like solution is there which is having pale green color as we are seeing here, right? Okay, so now I told you which is more reactive. Chlorine is more reactive than bromine, right? Therefore what happens here? So this chlorine, when we are adding from this conical flask to this potassium bromide, what happens here? So KBr is there which is a colorless solution. To that we are adding chlorine. So to the potassium bromide we are adding chlorine. So what is the change here we will be observing? So here it will displaces. See, chlorine is more reactive than bromine now. So chlorine will displaces this bromine and forms KCl, and Br2 will be formed. Okay, Br2 will be formed. So this Br2 solution which is having this reddish brown color. So what is the color of this Br2 bromine? So it will be reddish brown. So initially we have pale green color. During this process it will be having now red is brown. So what it is indicating? Bromine is formed from this chlorine. So how this process is taking place? Because we know chlorine Cl2 is more reactive than bromine, therefore this Cl will displace this Br minus from its solution, because Br minus is very less reactive than this chlorine. So this is the reason. I hope it is clear, because more reactive element will displace as a less reactive element from its solution, right? Clear? Okay. Now tell me which of the following reaction is possible? Which of the following reaction is possible? So first one is KCl plus Br2 giving KBr plus Cl2, and option 2 KBr plus Cl2 forming KCl plus Br2, and one more I am writing here, option 3 Ki plus Br2 forming KBr plus I2, and fourth one I am writing KBr plus I2 forms Ki plus Br2. So this is what the things I have mentioned here. So try to understand this and try to answer this. Okay. So here every time you can take 2 moles, 2 moles, 2 moles, 2 moles. Therefore this is also 2 moles, 2 moles, 2 moles. Yes. So this is the balanced reaction anyways. Okay. So try to answer, try to identify the option which are the following are possible, which are the following are not possible, and tell me in the comment box. So homework question. So identify which are possible. If 1, 2 are possible, write 1, 2 are possible, 2, 3 are not possible, 3, 4 are not possible, like that. So correct answer you write in the comment box. I will be explaining there if you have any doubts. Okay, we will discuss in the comment box. Okay, then next, what are the key takeaways here we have? So remember these points. So displacement reaction involves a more reactive element displacing a less reactive one, right? This is the first point. The reactivity series helps predict whether a displacement reaction will occur or not. So what it will helps us? So reactivity series will help whether a given chemical reaction will taking place or not. Okay. If a more reactive element is there, so that will displaces the down one, the less reactive elements from their solutions. Okay. But vice versa is not possible, right? Okay. So the next one is metals can displace the other metals or hydrogen from their compounds. Yes, this is also possible, because if this metal should be what? This metal should be more reactive. Okay. Now more reactive non-metals can displace less reactive non-metals. Yes, just now we have seen halogen case. Fluorine, chlorine is more reactive than bromine, iodine, that one. Okay. Next, observing the color changes, gas evolution, next metal deposition can be indicated displacement reaction. Yes. So we have seen hydrogen gas is liberated, and the last case pale green is converting into orange reddish brown, that is bromine case. So what is that things? So we have seen evolution of gas, deposition of metal, copper metal is deposited, at that example we have seen. The next evolution of gas we have seen, color change also seen. So these are the things happens in displacement reactions. Okay, this is also clear. The next double displacement reaction. What exactly double displacement reaction? So previously we seen displacement of like one element, right? So here two elements will be seen here. So a double displacement reaction is a chemical reaction in which two compounds will exchange ions to form two new compounds. So let us say AB is a compound, CD is another compound. Okay. Now what happens? So now a new compound is formed between AD and BC. So we got a AD compound, a new compound from AB, CD, and we have another new compound CD, like this. Okay. So now what happened? Here both this and this, the two ions are exchanged. The compound exchanges ions to forms, two compounds exchange ions to form two new compounds. Yes, two new compounds are produced here. Okay, I hope this is clear. I will be giving you few more examples. Okay, generally occurs in aqueous solution, often produces a precipitate. Yes, So generally whenever we are getting this kind of product, so one out of this at least one will be precipitate form, okay, or precipitate, or sometimes gas, or sometimes water is also formed, okay. This is a general reaction I have shown you. Let us see some characteristics and the next some examples, okay. So it involves two ionic compounds. In the double displacement, two ionic compounds will be involved, therefore they exchange their ions and forms new compounds, okay. The next, exchange of ions between the reactant takes place, right, often results in a formation of precipitate, which is insoluble salt, okay. So insoluble compound is formed, that is what the precipitate here we are saying. A gas is released, or a neutral like water like compound is formed, okay. So look here, so I have taken AgNO3, which is silver nitrate solution here, and aqueous NaCl salt solution is taken. So when we mix up them, so we will be getting AgCl, which is a white precipitate, is formed over here, okay. So this is what like see, from here sodium is displaced by this Ag, therefore the Ag and Na are displaced like exchanged, therefore we are getting AgCl and NaNO3. So two new compounds are formed from these two compounds, right. So this is what double displacement reaction, okay. Out of this one is precipitate over here, clear, right. So here also BaCl₂, barium chloride and sulfuric acid. So when these two are combining, we will be getting barium sulfate. So this is also precipitate, okay. So this down arrow represent formation of precipitate, okay, and HCl is also formed. So here also barium and hydrogens are exchanged, they are displaced, right, they are exchanged. So two ions are exchanged here, therefore I can say this is also double displacement reaction. Barium, hydrogen, H plus ions are exchanged, okay. Copper sulfate, okay, and H2S gas. So look here, copper sulfide is forming, so which is again a precipitate, okay. So copper and hydrogens are exchanged, therefore we are getting copper sulfide and sulfuric acid. So this is also double displacement reaction. So in three cases we are seeing one precipitate, okay. Other example, barium chloride, sodium sulfate. So what is the product form? Barium sulfate, already told you that is a white precipitate, barium sulfate is a white precipitate, again double displacement. Again in neutralization reactions also HCl NaOH, so H and Na is displaced, we are getting NaCl and H2O is formed, a salt plus water. Neutralization reaction is also considered to be double displacement here. And the gas formation, see Na2CO3 HCl. So what is the gas evolved here? CO2 is gas is evolved, a salt is formed and water molecule also formed, okay. Then next we have precipitation reactions. So what exactly a precipitation here is? Precipitation reactions is a chemical reactions in which two aqueous solutions react to form an insoluble solid. An insoluble solid is formed, that is what we are considering as precipitate. So it is called as precipitate. So this precipitate settle down or appears as a cloudiness in the solution, okay. So cloudy mass will be appeared in the test tube. If you are doing in the test tube, that reaction is done in the test tube, then we will be seeing a cloudy mass. Otherwise that cloudy mass will settle down at the bottom, which looks like a precipitate, okay. I hope it is clear, okay. That will be insoluble there, insoluble in the solution, that's why it is like having at the bottom of the test tube, okay. Now general form, how we are writing AB CD, so it is forming AD and CB. So this is, see, here also exchange, right. So A, D, a new compound, B, C, a new compound. So here here we are having like for particular substance. For example, here if I writing zinc, so here zinc is a metal now, so we should represent them in the solid form. So if we are writing H2 gas, I explained this already. Since it is a gas, so we should write its physical state G here at the subscript, okay. So AB aqueous solution, CD aqueous solution forming AD a solid, CB another aqueous solution, like that. So their physical states are mentioned here, okay. I hope that is also clear, right. The next thing is here the key characteristics. What are the key characteristics here? Involves two ionic compounds. Yes, two ionic compounds are involved in the aqueous solution and they exchange ions exchange their places, right. Okay, one product is insoluble salt precipitate. Yes, so here I told you, I will show you one reaction. visible change, formation of a solid. So what is a visible change we will be seeing? So by doing, if we are doing in the test tube, so it will be seen to our naked eye. So just there will be a mass is formed in the test tube, there will be a precipitate at the bottom of the test tube will be observed during the reaction. Okay. So now silver nitrate, whenever silver nitrate and sodium chloride is like added, so what happens? A white color AgCl precipitate is formed. So white precipitate of silver chloride is formed, one precipitate and one salt is formed, right? Then next, here barium chloride and sulfuric acid, just now we discussed similar example. Okay, barium sulfate, again a white precipitate is formed. Similarly copper sulfate, hydrogen sulfide, so here also we are getting copper sulfide, which is a precipitate here. Okay, so one precipitate is formed from the aqueous solutions. Reactants are like liquid, either in the liquid form or in the other states, but not in the solid forms here. Okay, so these aqueous substances both are combining to form a solid substance, that is the precipitate copper sulfide is formed. Okay, and yes, this is about the discussion. Okay, so we have discussed completely about, I mean whatever the required things are there for displacement we discussed, and few general applications also discussed, and double displacements and precipitation reactions are covered here. Okay, so in the next session we will be discussing about redox reactions, that is what, reduction and oxidation reactions. Okay, so stay tuned with us. So and if you really like the content, please click on the like button and share with your friends, and don't forget to subscribe. Okay, thank you for watching.